Okay, excellent. Thank you so much for joining me for this panel. So today what we want to discuss what is the state of the art and the future of AI. And let's start with a short introduction. Can you maybe introduce yourself briefly? Let's start with Grigory.
Hi, I'm Grigory Sapunov. I'm CTO and co-founder of Intento. I'm also expert in AI, and I'm also Google developer expert in machine learning.
Excellent. Mikhail.
Hello, everyone. My name is Mikhail Burtsev, and I'm head of Deep Learning and Neural Networks Lab at Moscow Institute of Physics and Technology. And we also develop our own open source framework for conversational AI, which is called Deep Pavlov.
And Sergey. Sergey, are you muted?
Oh,
yes.
Sorry. Hi, my name is Sergey Markov. I am chief of the ML R&D subdivision of Sber Devices team in Sberbank, and I am working on a wide range of ML models and artificial intelligence, of course.
Excellent. So I know, Grigory, that you have done, like every year, you are doing the great presentation about what has happened in the field of AI during the last year. And it takes like 1 or 2 hours. Can you maybe share that very briefly, like in 5-7 minutes, what has happened during the last year? What's the significant advances of the last year in AI?
Sure,
you can
I'm
share
ready.
your screen. Yeah.
Mm-hmm. I'm sharing it.
Yeah, excellent. Yeah, I think we see it.
Mm-hmm. Okay, great. So I'll try to pack all the interesting things or the most important things from my point of view into 5 minutes to leave some time to discuss. I think one of the most important things during the last year was the transformer models. Transformer, as you know, is a new neural network architecture emerged in 2017. And during the last year, we saw a lot of improvements, and I roughly pack them into 2 groups. First is large models, usually pre-trained models, and importantly, it includes cross-lingual models. You surely know GPT-3. There are also some regional models like a Russian version, thanks to Sergey's team, or Chinese version. There are also less known but still very cool T5 or MT5 from Google, BART from Facebook, Turing, NLG, and other Turing models from Microsoft. So it's a huge family of models that can be useful in very broad range of tasks. And
Grigory, sorry, I think we're having some problems with your screen sharing. Can you maybe just try it once more? Reshare the screen, because it appears to be like flickering.
Okay, trying again. Can you see it now?
Yeah, looks good.
Mm-hmm. And the second important group is architectural innovations in transformers. There are a lot of different innovations, some of them related to efficiency to process larger data streams. Another group is related to application of transformers to other data types, not only text, say image transformers and recent versions of it. And another group is augmenting transformer architecture with some new things like memory or something else. And this is a very open field, and we'll definitely see a lot more innovations in the recent future. And get involved in it. You can bring your own new research into production, and transformer is kind of Lego. You can create many different things from it. Second important trend from the last year, I think, is biology and medicine. And you've heard that AlphaFold 2 recently got great improvement in the CASP competition. And for me, this picture looks pretty similar to the ImageNet moment of 2012, when neural network came to image classification and did a huge progress in the improving quality of these things. And AlphaFold is not the only achievement of the last year. There are different other important achievements, research, and models. But AlphaFold, I think, is just one most well-known example of it. And I believe biology is one of the areas where AI could significantly improve quality of our lives. Another important area is education, I think. Third important trend is hardware innovations. It's not the topic of the last year. It happened early as well, but last year we see a lot of different cool things like NVIDIA new Ampere architecture. We know that new Google TPUs do exist, new Apple processor. There are a lot of neuromorphic research, Interloiki and others. And there are many, many different other specialized processors like ASICs and so on, from Habana, GraphCore, Habana is now Intel, GraphCore, Cerebras, and so on and so on. So I believe we will see much more hardware innovations and keep an eye on it. Fourth thing is cloud AI. I deeply respect this field because for now, you do not have to build every possible solution on your own from scratch. There are hundreds of different APIs for NLP, computer vision, speech recognition, structured data, and so on and so on. You can use it from the cloud almost without any programming, just calling APIs. And if these general APIs, general models behind them, do not satisfy your particular case, you have an option to customize this model in the cloud, just retrain them or fine-tune them almost without knowing what is happening on the back end, without deploying your own infrastructure. So that's cool. For now, every small company can start using this model and tune it for their particular cases. So this is a great democratization of the field, I think. And last but not least is AI ethics field. It's getting hotter, and we see different news on this topic. Some cities on the planet ban face recognition, for example. There are some talks about malicious use of AI and about biases in the model. It's ongoing research related to interpretability and explainability and much more, many different topics. So if you want to make your impact in this field, get involved. It's a very broad field. You can make significant progress there. So I think this was the most important from my point of view things, but that's not the only things happened.
Thank you so much, Grigory. You mentioned large transformer models and natural language models, and Mikhail is the expert in this field. So, Mikhail, can you maybe elaborate on that, where this will take us, like what direction in this language model research is taking?
I think that right now, natural language processing is one of the most exciting and the most attractive areas in deep learning as a whole, because we have such big demand for natural language interfaces around us, because we have all these IoT devices, and we have a lot of smartphones, smart cars, smart speakers, smart TVs. All of these devices can be controlled by just natural language. You don't need to read manual to understand how to control them. You just need to say what you want them to do. And this is very important. I think that right now we have in some transition period when thanks to all this advancement in NLP, which are fueled by large language models, we have better and better understanding of the natural language. And this leads us to emerging of a special type of AI assistant, like a personal AI assistant, which can live in different devices, in our cars, in our homes, in our smartphones, on our computers. So you will have the same AI assistant which understands your language, which understands your thoughts, and helps you to achieve more in your life. And on the other hand, these AI assistants, they became a new entry point to the whole digital universe which is around us, to the whole internet. Because right now we have the smartphones and we have search engines, but if you have your personal digital assistant, you don't need a search engine anymore, because you just ask what you want to know and it will help you to find it on the internet. So this is why I think conversational AI and NLP is very, very important right now.
And you are developing the tools to help people create those assistants, right?
Yes, we have a project which is called Deep Pavlov. This is framework for building multi-skill AI assistant. Why multi-skill? Because it's we want to create progressively more and more smart AI assistant. We want to add skills to already existing solutions. So we're creating framework, and we use this framework, for example, in our as we are in the university, and our lab, our PhD students and graduate students, they participate, for example, in Amazon Alexa challenge, and we use our framework to build social bots with multiple skills, like 20, 25 skills for this challenge, and which can converse with people. And we open source all our technology which we have developing during the competition, and we hope that it will help to accelerate this field so people can create their own conversational skills, and then it will be much more easier. Today, before our panel, we have a demonstration how to build a bot on the Microsoft Bot Framework. But still, you need to build some solutions from ground up or use a small amount of templates. What we want to do, we want to create tools for people to create more and more different skills, and also to package them into smart assistant, into digital assistants. So then for you, it will be easier just to take already created skills by somebody else and then to use them for your open source AI assistant.
Thank you. So Sergey, you have developed some of the very smart AI assistants as part of the technology at Sberbank. So can you maybe comment a little bit more how smart we can expect those assistants to become in the nearest future and how it would affect our life?
Okay, I'll share some my ideas on AI perspectives. Just a second. So can you see my deck?
Yes, we can see it.
From my point of view, we are going, of course, towards AGI, towards artificial general intelligence, and so we should anyway to make huge improvements in current models to achieve the AGI state. The one problem is that the only example of non-disputable intelligence is human intelligence, and it's really hard to decide where our systems should be considered as really intelligent. It's really hard to predict how much things we should do to achieve AGI state, and which way should lead us to AGI. And of course, there are a lot of considerations based on the bionics perspective of view, because of course, when you have some bionic prototype and the human intelligence is exactly such a prototype, so the first steps, probably it's logical to get some insights from bionics. And it's a really interesting questions. Our airplanes don't wave their wings like birds. And it's really hard to decide how much future artificial general intelligence systems should be like human intelligence, or maybe they can be really different systems based on really different foundations, and it's really interesting to find some answer to this question in practice. And of course, it's really funny thing from my point of view that we in some way return to the basics. In 30s, in past century, there was a lot of ideas how should act our machines to provide us with the necessary computation power to solve intellectual tasks. And there was a lot of ideas. For example, John Vincent Atanasoff, who was creator of first digital computer, he spent some time creating some really hilarious analog devices like the cubes of paraffin, using them to make some calculations of some systems of equations and so on. And now we are also trying to find the right hardware architectures to provide us a better performance to achieve AGI state. And of course, there are a lot of questions about software part of the AGI, and there are a lot of potential ways. For example, maybe it's some mainstream connectionist models because of huge success in deep learning, and a lot of people considering that it's the only way to achieve AGI. But of course, there are a lot of some other non-mainstream ways, for example, spiking neural networks, or some completely non-connectionist models, some symbolic models, or some near-symbolic models, and it's still an open question which models will lead us to AGI. But of course, the progress in deep learning gives us some insights about the possible way, and we see some row of revolutions inside deep learning. We have such a lot of innovations in past 10 or 20 years by creating some completely new models. And of course, transformers is one of the maybe most widely known model to be like the candidate model for the future AGI systems. And there are a lot of research how to improve the basic architecture of transformer to achieve better and better results. From in one hand, our current generative language models look like really simple models. They just trying to predict the next token in a sentence. But surprisingly, a lot of intellectual tasks could be easily transformed into the form of predicting next token in sequence. For the past year, of course, the most famous result was GPT-3, and a lot of people consider that it's a really huge leap towards artificial general intelligence, because such a model could achieve really good results solving a lot of different tasks, not the only task. We are living now in a world of huge pre-trained models, but how we can use them in our industry, in our practical tasks. Of course, there are three most popular ways how to do it. Make fine-tuning of such a model for your particular task. For example, when creating some dialogue systems inside the virtual assistants, we using such approach. But of course, it needs a lot of computational time and, of course, a lot of data and so on. And there are two really interesting alternatives. The first one is to ensemble, to create an ensemble with some shallow model to finally achieve some results you need in your task. Or prompt design, which is considered as software 3.0. You know, there are a lot of really interesting implications in this area. Prompt design, you're now not designing a huge data sets, huge curated data sets. You're just working on some prompt. It's really small, but it's enough to drive huge pre-trained model to grasp the idea of your task. And there are a lot of other consequences for such models. For example, this renaissance of mainframes or cloud computing. We now again living in a world where computational power costs more than maybe time of programmers. It's really interesting. And also, we are now living in a world where we have a lot of cheap content. For example, it's easily to use GPT-3 to create some horoscopes, some rewritten news, and so on and so on. It's really easy to create some faster prototypes. Because you can just design some prompts for GPT-3 or other huge transformer model, and voila, you have a working prototype without consuming a lot of programmers' time. And of course, we are probably approaching a world of highly customized services and highly customized content for each customer. So we are able now probably to create some highly customized news, highly customized music, highly customized texts, and so on for customers. And of course, it's a way towards AGI, and let's see how much time we should now spend to achieve our result. And the final considerations on this area, which things we should probably try to achieve our goal. Of course, the reinforcement learning is really an important thing because our intelligence is based, of course, on some natural reinforcement process, and to create some socialized AI, we probably should create some reinforcement framework to updating it, and so it's probably it's a time to combine the huge transformer models with some reinforcement frameworks. And of course, we need some multi-model pre-trained models which will join together the texts and image and probably sound and so on. So memory transformers and other explicit memory models, probably it's a really interesting area to explore. Of course, we are continuing some upscaling, some more computational power to be invested into models. And and last but not least is our attempts to simulate brain processes, and of course some huge huge hardware potential enables us to make some more experiments in this area. So from my point of view, this is the first things to try for now.
Thank you, Sergey. You actually mentioned we have very little time for questions, and we in fact have a question. And you mentioned the models which come across images and natural language. And the question in the chat is, to which extent we can extend transformers to replace LSTMs for tasks like image captioning?
I think that there are a lot of ideas how to combine them, how to use transformers with some convolutional neural networks. You should just create some bridge between features of convolutional neural network and transformer natural language features. And there are a lot of ways how you can do it. So and I don't know which way finally will win the prize, but of course there are a lot of alternatives here, and of course to combining some image transformers with natural language transformers, and of course image captioning looks like some task where we naturally have some data. We can just to crawl internet and obtain some text data connected with image data, so it's captions for images.
Yeah.
But I think it's not the only data sets that could be used in such tasks. I like YouTube, for example.
Yeah.
You have some text and images there.
Thank you. So before we close, just maybe 1 minute from Mikhail and from Grigory. How do you see the future, like the next few years in the field of AI? What breakthroughs?
I think that we will see new breakthroughs in creating better language models, and also combining these language models maybe with other modalities like a video or images, and like creating multimodal models. It's what we are doing in terms of theory, but I also think that in terms of challenges, still the dialogue systems and conversational AI is the most challenging, because it combines online learning with pre-trained models, all these stuff for transfer learning and so on, because it's interactive. It's not like training on a static data set. You cannot predict exactly what the human will do in the chat. So it's much more interesting, and to create model which can online learn something from a user is a great opportunity.
And Grigory?
As for me, I see a very broad frontier from multimodal models, huge models, new architecture improvements, but two important things is AGI, Sergey mentioned it, and another thing is human augmented intelligence, because we have a kind of integration problems. We have a lot of narrow AIs, but it's hard to use them in an easy way. We have a vast potential of improving integrations with these even narrow models, and it could bring us much more efficiency in almost any area.
Right. Well, thank you so much for this panel. I think we have not covered half of the things that I wanted to, so we probably would need another one during the next conference. And with this, again, thank you so much. And we will now run short commercial before our next session.